Hi, in this video we will be giving an introduction to concurrency and discuss the problems arise in the concurrent world. We are group 26 and Helani Vaidyaratna will be giving an introduction to concurrency as student 1. I am Sadhana Chamika and I will be explaining the problems arise in the concurrent world as the student number 2. Sumal Pereira will be explaining the concurrency concepts and issues as the student number 3.
Introduction to concurrency. What is concurrent? Concurrency generally refers to events or circumstances that are happening or existing at the same time, such as concurrent uses of a computer program. Concurrent programming is a technique in which two or more processes start and run at the same time, but not necessarily simultaneously sharing resources and complete in an overlapping time period. This doesn't mean that the process would run at the same instant. Why concurrent programming? First one is reactive programming. Users can interact with the applications while tasks are running. As example, stopping the transfer of a big file in a web browser. Availability of services. Long-running tasks need not delay short-running ones. Example, a web server can serve an entry page while at the same time processing a complex query. Parallelism. Complex program can make better use of multiple resources in new multi-core processor architecture. SAMs, LANs or WANs. Controllability. Tasks requiring certain predictions can suspend and wait until the predictions hold, then resume execution transparently. Concurrent versus parallelism. There are some tasks that can start, run, and complete in overlapping time periods. This is what happened in concurrency. Concurrent execution is dealing with multiple things at once. In parallelism, multiple tasks run simultaneously. Single process or single core system not possible to achieve parallelism. Multi-core or multi-process system have parallelism. So on multi-core systems each core is capable of running one process at a time. Parallelism execution happens parallelly. A real-world example. For the sequential, there is a tourist spot where people go. So that restaurant has very nice coffee machine which properly try. So there is a group of girls which come to visit that place. Now they have queued themselves up in front of the coffee machine. They are waiting to have their coffee. They are getting it one by one in meantime. Some boys came there and they also queued themselves behind the girls. They are waiting for their turn. So, if we consider girls as a single process and the boys as single process, this is an example of sequential programming. If you consider girls are process 1 and the boys are process 2 and the process 2 is waiting for the total completion of the process 1. Until process 1 is not complete, process 2 cannot start. So this is an example of sequential execution. Concurrent. Another scenario is that let's boys say that we are in hurry. Our bus is getting late. We also want to leave early. Can you help us with that? Is there any solution? So girls say, yeah, we can have two queues. You just make another queue and we make this queue. And now one girl will have coffee, after that one boy, then one girl and then one boy. In this way they think that might get this thing a bit early. What is happening here is concurrent programming. because the process 1 and process 2 are actually happening at the same time. Their time periods are overlapping because the process of girls is happening, the boys' process also happening at the same time. This is an example of concurrency. Parallelism. The owner of the coffee machine is quite kind and he knows that he has one more machine. So he just bring it and install it there and boy make one queue in front of the old machine and girls make a queue in front of the new machine. And now we can actually say that the task is going to get speeded up and they are going to get their buses early because boys are also getting their own coffee machine. Girls are also getting their own coffee machine. And now both the task processes are occurring simultaneously. So they are not waiting for their turns one by one. This is an example of parallelism. So that's it. Thank you.
My friend explained why concurrency is important and why concurrency is difficult. Now we are moving to concurrent world from the sequential world. In simple terms, from a single thing happening at the time to multiple things happening at the same time. In this section, we will be discussing the new problems that arise in the concurrent world. We will be discussing these two classic concurrent problems. We can use these to illustrate issues, problems, and solutions that arise in concurrent programming. First, we will look into the updating a student's bank account problem. Consider this scenario of various updates to Rick's bank account on his first day at university. Initially, Rick has a balance of $100 and student loan company deposits Rick's loan of $1,000 for the term into his account. Rick treats himself to an iPad for $400. Rick is his grand's favorite grandchild, so she also deposits $500 for the term. The bank manager makes no charge if an account is in credit, but to protect his bonus, he will charge $50 a day if an account goes overdrawn. So we have four characters here who are directly dealing with Rick's bank account. They are Rick, the student loan company, and Rick's grand, and the bank manager. So what will be the balance of Rick's account at the end of the day? Let's see with the characters action. Each of the four characters perform the same sequence of actions. First, they read the bank balance from the bank and then calculate the new bank balance that results from the action, write the bank balance back to the bank. So, if everything goes okay, which means Rick has the initial bank balance of $100 and bank deposits the loan company deposits the $1,000 and Rick withdraws for the $400 for the iPad and his granny deposits $500. So he has a 1,200 bank balance. So he can spend all day work on iPad, improve his buildings on Minecraft. If everything doesn't go like that, just imagine a scenario where Rick withdraws money before the loan company and grant deposits money. So he have only the $100 which were initially in the account and he withdraws $400 resulting minus $300 in his account and When the account goes overdrawn, the bank manager charges $50 a day. So it results, they charge his account balance to $350. So he will have to get a job and pay off his overdraft. So see, the sequence matters. Let's go dive into dining philosopher's problem now. The dining philosopher's problem is originally due to Dijkstra 1965 and later developed by Orr. The dining philosopher's problem is used to illustrate various problems that can occur when several processes are competing for limited resources. I will be explaining the dining philosopher's problem now. There are 5 philosophers who spend their time alternating between thinking and eating. After they have thought for a while, they get hungry and enter the dining room and sit at their allocated place in the table. In the middle of the table is a bowl of spaghetti. There is a chopstick between each pair of philosophers. Before an individual philosopher can take and eat some spaghetti, he must have 2 chopsticks, one taken from left and one taken from his right. The philosophers must find some way to share the chopsticks such that they all get to eat. Behavior of each philosopher is a cycle. So let's see what is a philosopher's behavior. First they think, then when they get hungry, they enter the dining room, sit down at their allocated place. Then they pick up the chopstick on their right, and then they pick up the chopstick on their left, eat the spaghetti, and then put down the chopstick on their right, then put down the chopstick on their left, leave the room. So in this, several processes are sharing the limited resources. So some issues arise by following the above scenario: shared resources and associated problems of interference. If concurrent activities are allowed free access to such objects, this leads to need for mutually exclusive access to shared resources. So, we need to use some of the coordination, that is, synchronizing their actions. Checking the required properties of concurrent programs, making sure absence of deadlock. When there is a deadlock, the program stops and make no further progress. So we have to make sure the concurrent programs have the absence of deadlock. Correctness properties are generally described as either safety properties or liveness properties. Safety properties can be elaborated as a program not reaching a bad state, and a liveness properties can elaborate as a program eventually reaching a good state. So I'll be winding up the part 2 of concurrency and the problems arise in the world of concurrent.
So in the earlier section, you learned about the dining philosopher's problem. In this section, we will discuss about the concurrency concepts and issues that might have arisen during the role play. So there are 5 main conditions that prove the concurrency concepts. So the first one is race condition. And the second one is synchronization and synchronization mechanism. Third, protection mechanism and critical sections. Fourth, interference. Fifth, and the final one is mutual exclusion. So the first point, the race condition. As an example, when a number of processes are executed in parallel, the speed at which they execute cannot be determined. So, when we have parallel processes executing, we cannot determine the speed in which they are executed. Also, we can say as if one process is waiting for input from two other processes, it cannot be determined beforehand which will produce first. So, this is the typical scenario which is referred as race condition. For the second point, synchronization and synchronization mechanism. If we continue the example that I earlier explained, for that problem, a mechanism must be introduced to coordinate and control the order in which processes execute. So, there should be a proper mechanism in order to coordinate and control in order which processes execute. So these types of problems are usually solved by synchronization mechanism. So the synchronization should have the following properties. It should have the ability to detect actions performed by interactive processes. It also should have the ability to permit the transfer of data at appropriate time. So those 2 points are important properties. So these properties require that communication between dependent processes and their synchronization always go together. So we must need to have these properties. So the next point is protection mechanism or critical section. A synchronization mechanism must be augmented by a protection mechanism to stop interference between concurrently executing processes. In other words, it means that if it needs to access to share resources such as variables, time printers must be restricted to one process at a time. So now let's see what is critical region or a section is about. The definition is the sequence of statements in a process which require exclusive use of shared resources. So, in our program, we might have a sequence of statements in a process which requires exclusive use of shared resources. So, we cannot have two processes accessing, so the sequence of statements in a process which require exclusive use of shared resources is called a critical section. So the interference is avoided ensuring by 2 points. as the first point is no two processors are executing the critical section at the same time. And the second is once the process is executing its critical section, other processors are prohibited to enter that area so that it has a locking arrangement. So that will be end. Thanks for watching.